Hi there, it's me, Matt Lane, co-host of Because of the Universe, and it seems like you have missed a show, but don't worry, here it is. We hope you enjoy it.
Across campus, online, and on 12:51 AM. This is your student radio station.
Good morning, it's 11 o'clock on Saturday, and you are listening to Because of the Universe, your fortnightly satirical science radio extravaganza, with him, the Sherlock Holmes of modern physics, only with infinitely more sulfur, tungsten, and silver, aka swag. It's Harry Manners.
Wow, you're right, that was extraordinary. Thank you very much. And here's Matthew Lane, chieftain of the Hooded Council, master taster at Ben & Jerry's headquarters, inventor of the world's first reverse paraprosdokian.
You know, I don't even like Ben & Jerry's ice cream. I realise that might be controversial.
That's it, we're leaving.
Oh dear.
Yeah.
Okay, I take that back. Harry, I would quite like a copy of all of your introductions, please.
Oh yeah, we'll have to post them up online.
Frame them on a wall and we'll put them on the Facebook page.
We'll have to cut them all together.
Brilliant. So this is Because of the Universe, your satirical science radio panel discussion extravaganza. We're going to be talking about some really... Ducky has actually told me. He's told me in advance what we're doing. He's in the studio.
He is.
Everyone.
He's actually back for the first time this term, I think.
I know. It may even be. Ducky the Soft Duck is back in the studio. Just to fill you in case you don't know, the show is his brainchild. We are his protégés. We love him. And he comes up with the question each week, and he's given me a clue. The thing that we're going to be talking about is really, really exciting. Well, I'm excited.
Yeah, I think this one's going to be really good.
It is going to be good.
Yeah.
It is going to be good.
Not like the usual filth.
Not like the absolute drivel. No.
No. We might do something vaguely rigorous today.
Today is going to be extra good.
Yes.
Extra good. Also, shout out to my nanny who's listening. I love you very much.
Hello, Matt's nanny.
Yeah. Okay. Let's get on this bus and drive it somewhere. Let's have a look at some news.
Yes,
Harry,
absolutely.
Why don't you go first?
Great. I'll start us off with the news that the UK Space Agency has pulled its finger out, and it's successfully implemented key technologies.
What did it pull its finger out of?
Of nothing, as in it's engaging.
Oh, is that a phrase?
With life. Yes, that is a phrase in the English language.
That's something new every day.
Thank you very much for the inappropriate interruption. For anybody watching on webcam, Matt has just turned away from the studio to laugh. Okay,
sorry for interrupting.
News. Starting again, the UK Space Agency has pulled its finger out and successfully implemented key technologies required by the groundbreaking PISA Pathfinder, which aims to detect gravitational waves in space. So that's something that will open up a new age of research in astrophysics and cosmology.
So this thing is going to be... is this going to be something they launch in space? It's not ground-based?
No, it's going to be launched, yeah. So this is essentially a key piece of the technology which has been built in the UK, and it's... the mission is a demo, essentially, of a future mission predicted for the 2030s, and it will use a system of satellites which will use interferometry to detect gravitational waves.
That's impressive, because the way we do it now is we build these...
yes, enormous...
People know about it, these ridiculously long tunnels.
Yes. So essentially the idea is to forego that, and then you utilise the vacuum of space to essentially use a linear accelerator. So you just have this cloud of satellites which do it for you.
That's good.
Yeah, absolutely. So Airbus Defence and Space are due to integrate the results in the final run of a batteries of tests in Munich, and then they'll set off for French Guinea for the launch in September.
Wow, I know we say this every other week because there is something space-related happening every other week, but
there is.
Boy, are we enjoying everything space-related at
There's
the
a
moment.
huge amount going on, really. We've said it before. We said it earlier this year, but
say it again.
It's not tailing off at all, is it?
No.
There's a huge amount going on. Just another little note on the end of that story is that this is the first time that an ESA mission, so the European Space Agency, has been led by the UK since 1986.
Really?
Yeah.
Who's been leading them most of the time?
It's usually France.
Well,
because
let's get the 100-Year War started. Let's go for the next 100 years. We do it.
Okay,
that's what I say.
Yeah.
Great.
Well, I hope this keeps going.
Yeah, I've got one.
Oh,
it's
good.
Australia related.
Yes,
and
I'm hoping for something hilarious.
For anyone who has listened to the show before, you will know that we try as hard as we can to mock Australia in some way. Not the people.
No,
we've actually
never.
No. Hold on.
Well,
because. Do you remember when they went and buried their heads in the sand in protest?
I do remember
about
that,
Australia's the government's stance on climate change.
Yes.
Well, we defended them then. We said, we're with you, we're behind you.
Absolutely.
Just most of the time we don't do that.
Yeah.
And I've tried really hard to find something that we can laugh at. And I've failed.
You failed.
I've
You failed to find something ridiculous going on in Australia.
I know.
It's
And,
a continent.
but this, you see, that's the terrifying thing.
Nothing funny happened.
Nothing funny happened.
Is that that itself is quite
Is news.
Yeah,
right?
that's quite newsworthy.
But on a slightly more serious note, I do have an Australia story. I apologise that it isn't mock-worthy. They've just connected up the world's first grid-connected wave power station and activated it
Ah,
off
right.
the western coast.
So this is
I can't
tidal power, is that right?
Yeah,
Right.
it is. So I can't find any. I can't find any statistics that have enough context to be able to tell whether this thing is worth whatever it cost or
Right.
whether it's just.
Well, this
basically-
is something that's often billed as being, by governments, it's often billed as being this huge next wave of technology, and then by anybody who's an academic or anything, absolutely
They just
slaughtered.
laugh at it.
Yes.
Yeah, exactly.
So this is quite interesting, actually. I'm
It is.
curious
They've
to see
actually
what
done
goes
it.
on
I'm also
here.
confused as to why the Australians have done it when, as we pointed out, the Australian people had to bury their heads in the sand to
Yes.
mock their own government stance.
But
on
at the same
climate
time, it is quite fitting that the crazy Australians are the ones to implement the crazy idea.
Yeah, it is. It is. So this thing is there. There are plans for an even bigger one. They look like massive jellyfish,
Right.
kind of.
Just bobbing
these
in
big. Well, no, they're underwater.
Right. But how are they connected to the power grid?
I assume they just have cables that go down, but then in water. And
Yes.
is that? And I don't know.
I mean, and then ships can't get out, can they? Because they cut the lines.
Who knows?
Oh.
Who knows?
Well, yeah, it's
So it's a
interesting.
good thing.
Yeah, it's something
interesting
to keep
see
an
what
eye on,
happens.
absolutely. We should come back to this.
We should do it
in
because
next
there
term.
are plans for a bigger one. So I wonder whether actually part of it is because you can turn the things into a desalination plant as well, because
Right.
you've got a source of online power.
I see. So that's quite valuable in a place like Australia.
I imagine
Right.
so. Harry, have you got another story?
I have. This one's really exciting. You've probably heard about this, guys. So, a neural network, which is a computer program with the ability to learn in a manner analogous to the human brain, has successfully learned to play computer games perfectly from scratch, such that they are, for all intents and purposes, unbeatable. So, the remarkable thing about this is that the AI called DreamMind has learned the rules for these games from scratch. So, just merely by observing the games being played, it's deduced the rules and subsequently learned the best ways to win. So this kind of technology is seen as the next step for machine learning with regard to speech recognition and super smart personal assistants, which require, the principles which are practically unprogrammable. So it requires interpretation and implementation of myriad social idioms, irregularities in speech, things like regional differences in accents, the things that you can't individually program for. It's something that a neural network is ideally suited for. So this might be the route to making machines genuinely versatile. So a true AI.
What I find interesting about this is it doesn't even require much computer power. So it's a relatively simple computer. The interesting thing here is the algorithm that Google have written for it.
Really? I haven't seen this.
So it's the algorithm that's impressive.
Really?
I have no idea how it works.
No, because it's...
But the computing power is small. It's a regular computer.
It is amazing, because it seems to be an intractable problem when you think about it on the face of it. How could you possibly break that down into a series of subroutines which enable a machine to look at something which is incomprehensible to it in the first instance and then deduce a series of rules from it? It seems impossible, and yet it seems to have happened.
Yeah.
It's incredible.
Playing the game over and over again and learning from its mistakes, the algorithm learns first how to play the game properly and then within a fortnight how to win.
Within a foot, that's amazing.
Is what this says.
That's incredible. To be now unbeatable
I know.
in those games.
It's exciting.
Yes,
I find
absolutely.
it very exciting. I've got another one.
Lovely.
So we're actually going to do a show on a topic that will encompass both of these next two stories. We're going to do a show on it next term.
Okay.
And the two stories are 3 men receive bionic hands that they control with their
I've
minds.
heard about this. This
is the
amazing.
first one. And I'm sure you saw a while back there were a couple of emotional videos that we love our emotional videos on YouTube, and everyone was kind of excited about them. And it was a woman seeing her baby for the first time with a pair of sort of electric fake glass eyes things. And now a man seeing his wife after quite a long period of time. So it's this kind of bionic
implementation of...
I find it very exciting. The integration of technology into humanity, yeah. So the 3 men receiving bionic hands is great. They're 3 men in Austria who obviously very badly wounded either in a car crash or as a result of a climbing accident.
Right.
2 of them had to be amputated, and I think one of them still has the hand. They just can't use it.
Right.
So what the biologists, what the tech guys have done is they've grafted some muscle from the leg onto the end of the limb. And then used sensors on that muscle to train the people to essentially access the regions of the muscle, and then they can connect that muscle up to a program, and then that means that the men are able to move a virtual limb. And then where the computer's reading off the electrical signals in that muscle, and then they connect it up to this prosthetic, and it's about 9 months to a year from the beginning of that process to the end of it. But I'm going to post a video on the Facebook page of these guys with these prosthetic hands who are it's literally their mind telling them what to do, and it's impressive the level of dexterity that they have managed to regain.
That's excellent.
And then in the case of the eyes, it's this one I find more impressive because the eye is so complicated.
Yes.
It's 2 cases. One where someone is blind in the center of their vision, but they can see in the periphery.
Right.
And it basically uses a very impressive camera to relay information to an LED that then shines the light to particular places on the retina so that the person can see. And then in the other case, it's literally, it does everything for you and sends the electrical signal to the brain.
That's amazing.
Now, you can't see in colour, you see in kind of a juddery black and white, like pixelated. But even so, this thing is impressive.
That's quite unbelievable.
It is quite unbelievable.
That's another one of those stories where you suspect that that's a joke.
But it's really not.
Yeah, it's like a science fiction standard plot, isn't it? The bionic eye.
Yeah. Do you have another story?
I have one more. I just want to briefly mention this because it only was announced yesterday. So NASA's Dawn spacecraft, which has been sent to study the asteroid Ceres and the dwarf planet Vega, has finally arrived in orbit around Ceres. So the spacecraft has been traveling out towards the asteroid belt since 2007, and it visited Vesta in 2011. Now in orbit around Ceres, it will begin collecting data in mid-April, and it will continue on until July, using its onboard instruments to measure Ceres' internal makeup and its gravitational field. So it's the first time that we've ever visited this body up close. So we've used Hubble to image it a bunch of times, but this is the first time we've actually seen it up close. And it's once again another space story.
It is, because there are so many.
They're all over the place. Yeah. Yeah. So I'm going to keep an eye on that, and we'll be mentioning that again.
We will be.
When it starts gathering data.
And finally, for the token slightly ridiculous, because we must have one, Matt story.
Lovely.
If I say these words to you, you're going to know what I'm referring to. White and gold or blue and black. It's the dress, in inverted commas. I find this entire thing incredibly irritating. There is a picture of a dress that has stormed across social media with people having heated arguments about whether or not this dress is blue and black or white and gold, and it's just
I can't say that I've seen this, if I'm honest. I've heard everyone talk about it. I haven't actually seen it.
Just so that you know, Harry, the other guests
are leaping back in horror at my ignorance.
This is serious ignorance. It's just a picture of a dress, and there's camp white and camp blue, camp white and gold and camp blue and black. People seriously arguing, and it's being used in advertising. It's being used in social media campaigns about domestic violence now. Is the kind of most haunting use of
So just to clarify, this is a picture and different people see different colours
Different people see different... I'm just going to show you the picture, Harry. So it's just a bit of a dress.
Okay.
Right. And you either see white and gold or blue and black. And I just want to put this to bed right now.
Yes.
Okay. The dress is blue and black.
Right.
The reason why people see things differently is because your brain receives 2 signals that it uses to determine the color of an object. It receives the background lighting, the context of the image, and then the light from the object itself. Now, the thing to realize there is that the light from the object itself isn't necessarily the color of the object, because that will partly depend on the background lighting. And then your brain uses those 2 signals to guess at the actual color of the object. And for this image, there isn't very much context. It's a very, very thin image in that you've got the dress, but not much of the background. So your brain doesn't get a particularly good context
reference point
signal.
I see.
And so some people assume that the lighting is dark. And if the lighting is dark, then the dress must be reflective, your brain reasons, and you see white and gold. Some people see it and think, actually, no, there's a lot of background lighting, therefore the dress must be darker, must be richer in colour, and so it is blue and black. But in reality, the dress is blue and black, and this has been confirmed time and time again. That's to bed, that's to rest.
Good. I saw blue and black when you just showed it to me.
Good. I've yet to see white and gold, but I don't care, so I'm not going to look.
Good. That was worth mentioning.
Okay, Harry, do you want to very quickly give out our social media in case anyone had anything interesting they wanted to say about any of the topics we talk about or news stories?
Absolutely. So you can get in contact with us with 3 main channels. You can go onto Twitter, so it's at COS the Universe, COS, COS the Universe, or AOL.
Because
so
the Universe.
Because the Universe at AOL.com.
Yeah.
And then Facebook, so it's facebook.com/Because the Universe.
Wonderful, wonderful. And they can also contact us on the Raw website.
They can. So if you want to go onto the Raw website, so that's rawradio.com, and you can jump onto the messaging board, and we will see that on the screen.
We will. So please contact us. Ducky is getting jittery. I can see. He wants to bring in the topic. So let's break for a song and then bring in the guest.
Lovely. So this is Bloodstream by Ed Sheeran.
Your student radio station on 1251 AM.
This is your Raw.
Welcome back, everyone. This is Because the Universe at 11 o'clock on Raw. We are talking about quantum mechanics.
Oh, we haven't introduced that yet, you numpty.
Sorry.
You've given the game away.
I've given the game away in the last minute.
I've been trying not to say what it is we're going to be talking about, and it's been really hard for me.
I've just been tweeting about it, so I've been gamed up.
Oh
for
my,
it.
that just... You don't put in as much effort as I do. I've had to hold this in.
Ruined the whole show.
You have.
I'm going, actually.
You're leaving?
Yeah, I'm leaving now. Okay, so I'm just going to give out our contact details quickly before we come back. So if you want to get in contact with us on Twitter, it's at COS the Universe, COS the Universe. Email, that's becausetheuniverse@aol.com, or Facebook, so it's facebook.com/Because the Universe.
It is indeed. Right, let's introduce the guests, see if they thought any of those news stories were particularly interesting, and then Ducky will kind of tell us the topic that I've already
given away.
So we've got Helen and Marianna in the studio. It's wonderful. Thank you very much for coming. Let's go to Helen first. If you could tell me the year that you're in, the subject that you do, and give us the customary Because the Universe truth and a lie.
Okay, well, I'm in first year, even though I'm 22.
Whoa.
Whoa. I've got some competition.
Hey, that shouldn't be the most interesting thing I've said so far.
How old are you, Harry?
Oh, well, I'm 23, so I've still got you beat.
Yeah.
This is close.
Yeah. It's nice not to be the oldest person in the room.
Don't worry, he's ancient.
Yeah, don't worry.
Yeah.
No danger of that.
I'm an English literature student.
Uh-huh.
And my 2 facts that you have to discern whether they're true or false is one of the members of Mighty Boosh, Rich Fulcher, once rubbed his armpit on my face.
Ah.
And
one of your members of what?
The Mighty Boosh.
What is a taboosh?
Mighty Boosh.
The Mighty Boosh.
It's the Boosh.
I'm still clueless. What's going on?
They're a comedy troupe.
Yes.
Yeah.
Okay.
Yeah, Matt's not really engaged with the world.
Okay, though.
Yeah. That's not fair.
And the other one is Slash from Guns N' Roses once rubbed his armpit on my face.
Wow. Well, either is impressive.
Yep.
I mean, if both in the same day, that would be...
Smelly.
Yeah. Well, because I kind of know about this, I've heard that of your fondness for certain things already, so I'm going to say, Matt, what do you think?
I don't know what either of those things are. What is Slash? What is Guns N' Roses?
Oh dear.
What is Kaboosh?
No,
What's going on?
No, not Kaboosh. It's The Mighty Boosh, which is a comedy kind of group, and then the Guns N' Roses is a band.
You know
so
what
what's
Guns
Slash
N' Roses
then?
He's a guitarist
in Guns
You've
N'
probably
Roses.
seen him. He's got like big curly black hair, and he always wears like.
Have I probably seen him, Harry?
No.
No.
You haven't.
Wow.
No.
No. Which one? So, how am I supposed to know?
Well,
I think the first one is true. Why not?
You think the first one?
Okay.
No, I've changed my mind. I think the second one is true.
The second one. In that case, I'll go for the first one. I think the Mighty Boosh.
Yeah, the first one's
The Mighty
true.
Boosh. Yeah, absolutely. Wow.
Marianna, make me feel worth something again, because at the moment I feel a bit kind of useless here. Tell us the year that you're in, the subject you're doing, and give us that customary Because the Universe truth and a lie.
I'm Marianna, second year physics student. My truth and lies are I can play 4 musical instruments and I can speak 4 languages.
Ooh.
Well.
Now we know that you speak more than one language.
Yeah. Well, are learning to at least. 4.
So I wonder if that's trying to be clever, and actually you play 4 musical instruments, but you know that we're gonna.
Yeah.
So I'm gonna go for the instruments.
well, just to be contrary,
Yeah.
I'll go for the languages.
Well, I do speak 4 languages. It was a
Wow.
double bluff.
Double bluff.
So I got both of them wrong.
Wow. What are the 4 then? So you speak English and you're learning Japanese
I speak Italian and
Italian.
French.
and French.
Okay.
Right. Well, wow.
Moving swiftly on because
Yes.
I lost. Let's bring in Ducky. So I'm bringing
Yes.
Ducky the soft duck to my ear. You're looking in on webcam.
Yes,
This is
you
the
can log
highlight
in
of the
right
show,
now.
right?
And watch
Uh,
this extravaganza.
Just gonna Ducky, tell me, what is our topic today?
He's looking at me rather pointedly as I've betrayed him.
What, Ducky or me?
Both of you.
Both.
As I gave the game away.
Okay, thank you very much, Ducky, for that. That's great. I'm glad that we know. Okay, so we're going to be saying. In fact, Harry, because you've already given the game away, why
Yes.
don't you introduce the topic?
The topic today is quantum mechanics. Is it real?
Is quantum physics real? That's what we're going to
Yes.
be talking about.
We are. So
I'm so excited.
a little bit more specifically, we're going to be talking about its relation to public perception.
Yeah, whether or not people think it's a real thing, what actually is the thing that we're talking about when we say quantum physics,
Yes.
and some other. And at the end, we're going to go kind of on a physics high. Basically, we're
Yeah.
going to go out on a physics high at the end of this term.
Just to highlight this to any listeners, this is our last show of the
Yep, this
term.
is.
So we are entitled to wrap up on something a bit nerdy,
Yes.
a bit more nerdy.
Yes.
Yes.
I mean, me and Harry have crazy glints in our eyes.
Yes. Well, that's normal.
That is normal.
Yeah.
Right then, Harry,
Yes.
you were alive in Copenhagen because you're so old. You were
was.
alive way back when.
I was there for the
when
Solvay
the
Conference.
physicists
Yep.
were all getting together to discuss this new strange beast that
Yes.
is become quantum physics.
Yes.
Do you want to tell us about that?
A little bit about the history of quantum mechanics?
Yeah, go on.
Okay, so essentially we draw a distinction between what we call classical physics and quantum physics, which is about the turn of the century, of the 20th century, that is. So we have people like Max Planck and Niels Bohr and Einstein coming along in 1908, 1910, that kind of area, and essentially they find that they are finding old physics lacking in being able to explain certain phenomena. So we draw attention to certain things like shining light on metals and so forth, detecting electric currents being generated, quantization of energy, which essentially is a fancy way of saying that energy comes in little blobs. And then they suddenly got together. In the most famous conference was the Solvay Conference, which brought together the great physicists of the time. So you have people like Marie Curie and Einstein and Bohr and de Broglie, Paul Dirac, all these people. They all came together all at once. It's like, the all-stars. It's almost like the Avengers being
That's a
gathered
really good
together.
analogy.
Yeah, I mean, that some of them were from Asgard, but we won't mention that. And yeah, essentially, this whole theory exploded over the course of about 3 decades. So by the time of the end of the 1930s or so, you have this established theory which completely revolutionized physics.
Absolutely everything.
Yes.
There was nothing that was left untouched.
No, and then
Right.
it's continued since then. Little details being tied up, but essentially the entire theory was just dredged from the ether in those few decades.
It
was
a
amazing-
lot of
amazing.
work was done by a lot of people.
Yes, it's truly incredible. I mean, just to try and learn it in a few years is just a bamboozling array of theory, which it seems amazing that they managed to get so far so quickly.
Yeah.
So it really was a meeting of the titans.
It was. Now, I feel as though we might need to give a little... I feel as though we may need to do a kind of case study thought experiment or something to try and clear up what it is, what are the ramifications of quantum physics. So I'm just thinking Young's double slit
Okay,
is
sure.
probably the best thing to do. Marianna,
Ah,
you're a physicist.
Yes.
Do you wanna walk us through the double slit experiment?
Sure. Light is shown through 2 slits, that are 2 aperture in an otherwise absorbing wall, and scientists observed the diffraction pattern that produces on a distant screen.
okay. Yeah.
That's it.
So that's relatively normal. As in we kind of all have an intuitive understanding of that. We all know that light travels like a wave, like water ripples.
Yes,
right.
we know from school.
And if you get two slits, and you have this is what you described, isn't it? You have that light going through those two slits. Then the waves that go through those two slits interfere with each other. So the highs of one meet with the high of another to give you a big high, and the high of one meets with a low of another to give you essentially zero, because they cancel out. And then on that screen, you get big high, big low, big high, big low, big low.
Yeah, you get these fringes.
Yeah, and we call that, like you said, a diffraction pattern or an interference pattern, or you call it fringes. And if you take a physicist
We've all
and you
seen
slap
them
them around the face and you hold that pattern up and you say, "What is this?" They will immediately say, "Oh, it's an interference pattern. Why are you slapping me around the face?"
Yes. That's commonly the standard answer. Yeah.
Everyone
it's
will
in the
know
book.
that. We know this.
Yeah.
Next time you're walking past a pond or a river, if you just look at the ripples, you will be able to see this. You'll be able to see.
I mean, you've probably seen from making splashes in the bath that you can cancel waves out like that. So it's analogous to that.
And so that makes sense.
Yep. We're all used to that.
Particles, though.
Yes.
If you did that with particles, say you had a heated cathode, which is a piece of wire that you get hot, so it's firing off electrons, and you replace your light bulb that was shining the light with this cathode. Electrons are tiny little subatomic particles. They're teeny tiny.
Yep.
And classically, we would think of them as balls or point objects, or something with a well-defined position and a well-defined speed.
At school, electrons orbiting their atom, their nuclei, like little planets in a solar system.
Exactly.
Yep.
Well, it's this description that you've just described there, that classical description of electrons orbiting like planets, that quantum mechanics destroys.
So this was the picture at the turn of the century of the atom.
It was, but then if you have that cathode and you heat it up and you've got electrons firing at these two slits, then what you expect, if your screen is now a phosphorescent screen, so it's got some phosphate in it, that means when an electron hits the screen, it releases light, and then you set up a time-lapse camera. So you build up an image of where these electrons have hit the screen. What do you expect? Well, classically, electrons travel in straight lines. So if it goes through one slit, you'll get a bright band there, and it goes to another, you'll get a bright band there. So you'd expect two bright bands.
Yes.
Okay. I mean, if you did it with tennis balls, that's what you'd get.
Yeah, sure.
That is what you would get.
That is what you would get. Yeah.
You do it with electrons. Harry, what do you get?
You get the same phenomena as you do with light. You get this weird diffraction pattern. You get fringes. You get highs and lows, as though the particles have interfered with each other.
But actually, on first glance, this isn't that surprising, because we know that in the case of water waves, well, water is just made of particles, and it's the collective group motion of the water that gives rise to this interference pattern. So maybe it's just you've got lots and lots of electrons, and there is some group motion like waves. So how do we test whether that is or is not the case? You just slow it down, so you've got one electron at a time.
The one little blob at a time.
One little blob at a time. And so, again, this has been done multiple time and time. And I did this in a classroom with light, not with electrons.
People have done it.
So again, here, you're expecting to get those two bright bands, classically.
Yes, because now we are talking about one particle. So one little slot going through at a time.
If you got an interference pattern, it would have to revolutionize everything you thought about the world.
Yes,
Harry, what did we get?
We got the pattern,
Which is bizarre, because what does this mean? This means that one electron went through both slits at the same time and interfered with itself, perhaps.
Which is absurd, isn't it?
It's worth saying that actually, and we'll talk about this later on, we're talking here about perception and interpretation.
Yes.
At no point are we talking about the real world.
No,
we can't really
not saying that there's a
knowledge.
blob which has gone through two things. That is exactly as you say.
But at least in terms of our perception or the way we interpret this mathematics, that's how it looks.
Yes.
It looks like it's gone through both. And so this is strange, because particles can't do that.
Well, classically they can't.
Classically they can't. And so this is a brilliant example of where quantum physics has to kick in. It says that, as de Broglie postulated, you have wave-particle duality, where it seems that sometimes waves behave like particles, sometimes particles behave like waves, and it seems to depend on the type of measurement that you make.
Yes, so essentially quantum mechanics in its various forms is a muddying of the water.
It is.
In respect to all kind of classical aspects of physics.
I much prefer it.
Well,
I know you say it's a muddying of the water.
As in, it certainly, it erased some hard lines which have been drawn for many hundreds of years beforehand. But still, I think, the main thing we want to address today is the fact that 100 years later, almost, it is very much 100 years, over 100 years since Einstein postulated his three annus mirabilis papers, and still the general public seems to interpret quantum physics as something rather fluffy and made up.
There's a definite amount of, are you just kind of pulling things out the air, scratching away at a blackboard in your room? Do you really ever look out the window at the real world?
Yes, there's no bearing on reality.
Helen, I just want to know, what do you think? Because remind me your degree.
English literature.
English literature. just as in, I know nothing about you as a person, so it might be that you're very up with it. You know what's going on.
Well, you are, a huge fan of science fiction and so forth. I would say that she is on the leading side of the general public.
As a non-scientist, since the three of us are physicists, our heads live in this strange space.
Yes.
So, as a non-scientist, when you hear people talking about this, about particles being in more than one place at more than one time, or interfering with themselves, or people saying, there is no such thing as particles, there actually only are waves, and waves don't even exist, it's just a mathematical formalism, it's something else entirely. What happens in your head when you hear that?
I just start playing music.
Elevating music.
It's dun, 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 dun. Even just the name quantum physics or quantum mechanics, it doesn't really sound like a real thing.
Quantum of solace.
It definitely
I just think
it definitely has a huge stigma about it, doesn't it? A sciencey thing.
Yeah. And like you said, I had this sort of general sort of view of, I don't really know how the bearing it has on real life. It's a weird sort of...
It's not really communicated because, we have to... something we should acknowledge here is that quantum mechanics is vital to the operation of almost all modern technology.
Everything. Absolutely everything.
Everything, all the gadgets in your pocket, the internet, it just wouldn't work.
Somewhere, someone has had to click play on a computer simulation that uses quantum field theory or density functional theory or one of these derivatives of quantum mechanics to work out what's going to happen.
Yes.
You can't not do that.
No, and yet people are at license to say, "Oh, that's just nonsense. It's just a bit of something made-uppy."
Fluffy. I think
fluffy.
I like that word that you used.
Well, people will feel entitled to tweet and Facebook about that using the machines that rely on it.
Yeah,
it's kind of it's very surprising that it's not really addressed.
Yeah, most of our lighting requires a quantum mechanical.
Yeah, all the LEDs that you're seeing. Absolutely rely on that.
Every single electrical chip that does anything.
Yep. Any laser pointers you point around.
Yep.
Anything remotely to do with that. The sun shining.
Yeah, that's true.
I mean, sunlight. That's kind of a big one.
Yeah.
You can't really explain how it works without quantum mechanics. So
the way that we see.
Eyes. Absolutely. Superconductivity.
Mm-hmm.
Something I want to talk about a bit later as well is it seems to play a huge role in biology, which is a new emerging field. I won't say too much about it because it's quite involved, but I think, if we have time, we should come back to that later because that's very interesting as well. And then there's the kind of new concepts which are on the very cusp of, leading science fiction, quantum computing, which is, almost a science fiction buzzword for weird thing.
Yeah.
But is a real thing, has been demonstrated, as well as quantum cryptography, which
that's been around for ages.
Yeah, absolutely. But, it's a thing.
Yeah.
It's a thing. It can happen. And it's the ultimate security measure. Definitely. And is, billions are being poured into this because, of course, it's unbreakable. Yeah. Everyone wants this.
Yeah. So there are two routes to take with quantum physics. One is to really emphasize all of these practical explanations, and that's your motivation.
Yes.
The other motivation is saying, the world isn't like how you think it is. What is it like? This is our best description. So there's a theoretical and a slightly more practical approach. I like the theoretical approach.
Oh, well, you shock me.
So I hope that we'll have a little bit of time to talk about some new interpretations of quantum physics.
Oh, I'm sure we will, and I'm sure, you'll still be here at 11 o'clock tonight talking to yourself.
Probably.
Yes.
Probably.
As usual.
Yeah.
Yep.
But there is this problem. There is this perception problem.
Yes.
Of this thing being fluffy, not really thought through, not really backed up in it.
In some ways, it is understandable because people's education seems to be essentially left off at classical physics. People's perception of atoms is still little solar systems,
which to some degree is understandable. Because everything you experience, everything you're likely to experience,
can be explained rather well using that model. It's quite simple. It's quite intuitive. It's easy to understand. It's relatable, and it's good enough for a basic understanding of chemical properties and all this kind of thing. And you can understand it in that sense because to make the jump then to have any kind of reasonable understanding of quantum mechanics does involve 1 or 2 years of undergraduate physics.
So and even then, we're taught orthodox quantum mechanics that nobody holds to anymore.
Absolutely, it's a defunct theory, which anyone in the academic sphere would laugh at.
Yeah.
And it's non-relativistic, so it doesn't even take into account anything. That even Einstein was around when he came up with the theory, so it's kind of a simplified version of something that was originally created. It's not even anything remotely rigorous, and yet it took us. We're in our second year, and we still don't understand that.
Marianna, do you have any thoughts as another physicist? Do you have any thoughts on why it is that some people? I mean, it seems there are in the non-science community there are two camps, really, aren't there? There's quantum. Put it on billboards, put it on herbal remedies, put it on film titles, and then there's the other camp, which is physicists with glasses in a dark room and a chalkboard. Yes. Not interested.
Well, I think most people believe that quantum physics doesn't really apply to them because it's not something that they can perceive. It's something that acts in a completely different scale. So to them, it doesn't really exist. Most people don't even know that quantum physics exists. As a matter of fact, they're not even familiar with the term. They just think that it's a sci-fi term.
Because it has really been embraced by science fiction, hasn't it? Yes. A lot.
It has, yeah. But something I find really interesting is the level to which many sci-fi writers don't even bother to look up basic quantum mechanics in a textbook before they write about it. They'll reference things as the quantum mechanical effects of the particle accelerator creating a time machine, and that's fine because it's quantum mechanics. No one actually understands it, so you can say whatever you like. And then the number of science fiction stories I've read which have nothing to do with quantum mechanics, and it's just used as buzzwords for weird thing. Yeah, weird thing, and therefore I'm free. It's laissez-faire, blank check. I can do whatever I want. And that is exactly an example of that because most writers aren't trained PhD scientists. They are just regular writers who like to write in a certain way. So it's used everywhere as just unknown. It's analogous to unknown territory.
I also think that Einstein might be a factor in why people don't really believe that quantum mechanics is real, why they think that it's made up. It's that when quantum physics in general first came out, Einstein tried very hard to make people realize that it was made up because quantum mechanics and relativity contradict each other.
Yes, absolutely. And also he tried in his later life to undo all his work. He said, I'm paraphrasing, but he says, God doesn't play dice with the universe. Yeah. Absolutely hated the idea of probability. But the
important thing to say about that statement is it was purely, that wasn't some high-flying spiritual statement. It was more that he just didn't think that from his perspective, the things he knew about the world, he didn't think that there could be this level of true randomness. And it's interesting we bring that up because in the modern interpretations of quantum mechanics, this is still something that people fight for, right? So quantum mechanics is dealing with one particle. Whereas when you go relativistic, by which we mean either things are moving very, very fast, then actually when things move very, very fast, suddenly particle number is not conserved, and that one particle might turn into 2 or 3 or many, many more. And so quantum mechanics ceases to be a good description of the world. You then have to have relativistic quantum mechanics, but of course such a thing can't exist because in quantum mechanics, particle number is conserved, which is why relativistic quantum mechanics becomes quantum field theory. Right? So even now, this issue about that true randomness that Einstein had is something that we still fight to try and sort something out. People really don't like it. Even modern physicists don't like it. To the point where there is another interpretation of quantum mechanics called Bohmian mechanics. Notice I say mechanics. I don't say field theory, so it's non-relativistic. But in Bohmian mechanics, there is no true randomness. There is randomness due to ignorance. And what they basically say is it's almost classical theory. So I find it impressive that this is a modern day interpretation of quantum mechanics, but it really is. In Bohmian mechanics, you say classical forces still exist. We don't need a different description for force. The classical description works. The only change is you postulate a quantum force. And there is this guiding equation in quantum mechanics called the Schrodinger Equation that is very, very important. And what Bohmian mechanics does is it says that the wave function, which is the thing the Schrodinger Equation acts on, there is a force that acts to drive particles because particles now exist separate separate to the wave function in this interpretation, that drives particles to the peak or the trough of the wave function. And so you get this extra force that means that those electrons, when they go through that slit, they don't travel in a straight line, nor do they travel through both slits and interfere. It goes through one slit, but the interference pattern formed by the wave function causes the path the electron takes to wiggle in such a way that the results you observe are an interference pattern. Wow. Not because it has wave-like properties, but because it just travels in this wiggly line. So in that example, it's randomness due to ignorance. It's because you don't know everything about the boundary conditions.
Well, that's really interesting. I think there's been a lot of terms in there that probably we need to explain more. So I think we should break for a song and then come back and maybe explain things like wave function and Schrodinger equation. We'll do that.
I wanted to throw it out there.
Yeah, that's a great start. So I think we're going to break for a little bit of Anna by Will Butler, and then we'll come back and we'll do that.
Yeah.
Okay.
You're listening to Your Raw.
Your Raw.
Your Raw.
On 12:51 a.m.
Welcome back, everyone. You're listening to Because the Universe on Raw. We're talking about quantum mechanics and is it real?
We are, and I just word vomited.
You just word vomited?
So
yes, you did.
I said a lot of physics because I got very excited for a moment
there.
You
did. We apologise profusely, ladies and gentlemen. We tried to sedate him before the show, but today I missed his dose.
It was just physics, and I got excited. So what we're going to do to try and explain some of that is we're going to hand over to our two guests. Because it's brilliant in that we've got a physicist and we've got a non-scientist, and so some of what I said there will have been
yeah,
because it were just words. So Helen, what didn't make sense?
When you were talking about the Schrodinger equation.
Schrodinger equation, yes.
Yeah.
Marianna, shed some light.
Yeah. Help us out.
As we said, particles behave like waves. So Schrodinger just modeled this using an equation. So he can show the wave behavior of particles. The only problem is that equation only encompasses the energy of the particle that is treated as a wave and their position. So it doesn't give a complete understanding of the system, but only those two parameters.
Okay. I vaguely understand that.
Yeah, essentially it's an equation which describes particles as waves.
So in the same way that A-level mathematicians and A-level physicists, and even to some extent GCSE, will know about what we call the Suvat equations, right? They're an equation that if you plot them on a graph, it gives you the path that a ball would take if you threw it. Right. It's got x, which is where the ball is, and t in it in this equation. The Schrodinger equation is the same, except it doesn't give you the path of a ball. It gives you this weird interference property of the wave function, but a particle somewhere.
Another term we should define is wave function, because that's another one throwing around and doesn't mean anything.
I'm sorry.
I think I've heard that before from lots of other scientist people.
So essentially, the wave function is the thing you plug in to the Schrodinger equation. It's the thing which I can see Matt desperate to jump in, so I am just going to bow out because this is your thing.
Okay, so there's the orthodox Copenhagen interpretation of the wave function, which says it's a probability. It's related to the probability distribution. So I'm going to give over to you in a minute, Marianna, to talk about the Heisenberg uncertainty principle.
No pressure,
right? But essentially, it's related to the probability distribution, which means it doesn't tell you where a particle is going to be. Mm-hmm. It tells you all the places it could be and where it is most likely to be. But you don't know until you measure it, so it's not deterministic, is the phrase. It is worth just saying, though, in modern interpretations of quantum physics, that isn't what the wave function represents anymore. It represents a whole host of other, even stranger things. And so the thing that we conclude two things. We conclude that the world is infinitely more complex and strange than the human is able to understand, perceive, interpret, intuit. And whatever description we come up with, it doesn't really matter. It still doesn't correspond to reality. It only corresponds to our perception. Marianna, Heisenberg.
Heisenberg's uncertainty principle. It just states that you can't know the position and the momentum of a particle at the same time. But just like it can be position and momentum, but there are also other pairs that cannot be known simultaneously.
Energy and time as well.
Yeah, there's a whole list of others.
Various components of just the angular momentum as well.
Yes, as well.
Yeah, so essentially it states that the more you know about one, the less defined the other is.
But I mean, Marianna, is this a limit on the resolution of our equipment? So is it that you can only measure so well?
Is it just,
or is this something more fundamental?
Well, the theory says that this is something more fundamental. I mean, it falls out purely from the calculations, and it's proven experimentally to be the limit that can be exceed. So
Right.
So let's say you've got your particle and you measure where it is very, very accurately, and you know that it's almost not moving, right? You then measure it again. What might happen?
You're saying you're measuring the position only?
Yeah.
Well, you wouldn't know the velocity precisely. You would just know whereabout it is, but it wouldn't even follow a straight path. It would just be almost what seems to be random.
So now when we take a measure of where this thing is, it doesn't even follow a well-defined path. It kind of jumps from place to place.
It's bobbing around.
Because otherwise you would be able to extrapolate its velocity as well.
Yeah.
You can't do that.
So this thing has weird.
Yeah.
That something that should be going in a straight line just isn't anymore. It's jumping around from place. And this relates to what we said about the wave function. If you interpret it as a probability distribution, then it might be there, or there, and it's a matter of random chance. And I'm gonna use some like dodgy language here, but I'm gonna say nature just chooses where it's going to be. From any of the places where it could be. Nature just chooses, and it's truly random. It's one of the interpretations.
Yes. And that is really one of the things that's why people find it fluffy, and it's counterintuitive. It's very strange and odd, even to people who are familiar with it. It's just
Einstein
weird.
Didn't like that.
Yes.
Bohm didn't like that.
I bet it makes people uncomfortable as well.
Yes, I imagine, because classical mechanics is so deterministic. It's very definite, and it's saying, yes, we know this about the world, and we can describe it, we have the power, and then quantum mechanics comes in and says, no, actually, you can't really know very much at all. There's a limit on what you can know, which is a new concept. It's still quite a barrier for people.
Yeah, and there are so many interpretations. There's that interpretation of things existing in all of space and all of time, all of the time, and then this just collapses when we observe it. But that leads to some strange implications about consciousness and the meaning of consciousness. Then there's the many-world interpretation in quantum cosmology that says there's an almost infinite, when I say almost infinite, I just mean very large, a very large number of possible universes that all exist in a superposition of states, and we are only one of them. That's a very...
It's often used in science fiction, isn't it?
It is. But maybe, you know what, would you like to come on a show next term just about quantum cosmology?
Absolutely.
As a sci-fi?
Yes.
Excellent.
Absolutely, yeah.
Great. So, Harry, you said that we want to close on talking about perception, and that I'm not allowed to do that because I've got pages and pages on my laptop that I want to say.
I mean, you don't even need to look at those pages. We could just poke you and it would all fall out.
So I'm going to let you close this show up.
Righto. And you're going to go and sit in the corner.
Perception, Harry. What is it you're meaning when you say perception?
Perception. So we're talking here about... There seems to be a fundamental difference between what the theory indicates and what we interpret from these equations. So we look at the Schrodinger equation. There's nothing in there which indicates what is called the Copenhagen interpretation. So that's interpreting we'll forgo the mathematics, and we'll just say that the wave function corresponds to a probability of a particle being measured in certain places. And there's nothing in the mathematics which says that. And also there's this thing where it seems that this is an infinite superposition. So it's all these different possible states. Because in the mathematics
it doesn't collapse. In the mathematics you should never see an electron here or there or there. You should see it in all of those places all of the same time, weighted by their probability.
Absolutely. And that is the main thing I want to close on, is the idea that this idea of collapse, is this term which it seems to be that, as you said, nature chooses. Suddenly, you're looking along the spectrum and it says, well, okay, well, the math says it should be in these places, and yet it seems that for some reason, nature has chosen that it's only going to be in one, and we say it's essentially collapsed from all these different ways lying on top of each other to just one.
Why is it not 30% here, 40% there, 10%?
Why do things come in blobs? Why is it, localized in one place? And that is something that is entirely due to our perception of what's going on in the world. And as you said, it ties hugely to consciousness.
Or the incompleteness of the theory. One of them.
Yes, absolutely.
Both. Marianna, you look like you're gasping.
Well, when you said, why is it not 30% somewhere and 40% somewhere else? I think that's actually what it is. Eventually, if you take enough particles, 30% will be in one place and 40% will be on the other one, according to their probability. And I think that's the main problem with quantum physics, is that the probabilities don't fall from the theory. It's something that seems to be able to describe bigger systems.
Bigger systems.
But can't accurately describe a small one.
Statistically, it works.
Yes.
If you look at, like you just said, if you do this many times, it's like with that electron, where you have one electron at a time going through those two slits. If you do that time lapse, you get an interference pattern, right? But one electron at a time, you don't get an interference pattern of one electron. It's quantized. It's one that field, that electron stuff field. I'm not going to talk about quantum field theory, but that electron stuff field is just there. It's localized. And why is it the important thing that I want everyone to take away? I have a complete agenda. The important thing I want everyone to take away, right? Who's listening?
We're all his prisoners, by the way.
Yeah, the door is locked. Is that
help?
You know, the universe is so strange. It's about time we all got a bit more curious.
Absolutely.
You know, because it's so strange. When we talk about things existing in more than one place at more than one time, the fact that it doesn't even now look like that's what the universe is like anymore, when you really get down to it, it seems even stranger than that. It's the most beautiful and exciting time. And I'm glad that we were born now and not back in Copenhagen when that conference was happening. We call that the golden age. I don't think that was the golden age. I think now is the golden age, because now we've got that basic model. We've got that basic quantum mechanics. It's this generation, the generation before us and before that, and the generation after us. It's our job to work out, how do we actually understand, interpret? You know, we are human. We can't just say, let's go with the maths and not think about it. No, we have to find a way of understanding this thing. And that's going to be the golden age, I think.
Yes, absolutely. We can now take this through and go forth. Absolutely. Thank you very much for rounding it off. That was a great conclusion to that, Matt.
Thanks,
and
thank
you've done very well curtailing yourself.
I know I have.
Well.
It's been so hard. Thank you very much, Helen. Thank you very
Marianna.
much, Marianna. It's
lovely
been wonderful
having you on.
for our last show of this term.
Absolutely.
We have been Harry Manners and Matt Lane. This has been Because the Universe.
We have.
It's the end of the term.
We will be back next term with any luck, and we'll be talking more quantum and sci-fi and lots of other nerdy things.
Joy of joys.
Joy of joys.
Have a wonderful Easter. Enjoy any revision that you have to do. And we're going to go out, same as we did at the end of last term, we're going to go out on a song very dear to our hearts.
Thanks for listening, everyone. Have a great Easter.